Let f be a polynomial function of degree 1 or higher of the form f of x equals all of this, where q and p are not 0. And q is the leading coefficient, the number at the very front of the polynomial, and p is the constant term, the last number in the polynomial. When we know what the q and p are, then we can find the possible rational zeros by taking the factors of the constant term p and dividing all of them by the factors of the leading coefficient, q. The Rational Zeros Theorem just states what all the possible rational zeros could be, not what they are. So when we get all of these, it just means one, more, or even none of them could be the actual answer. So let's go with the first one. F of x equals x cubed plus 2x squared minus 5x plus 6. And we're going to list all the possible rational zeros. So first off, let's just find out what p and q are. P is 6, and q is 1. And it's best just to kind of list all the factors off. And when you list the factors off, they have to be written as both its positive and its negative version. So the factors of 6 are going to be plus minus 1, plus minus 2, plus minus 3, plus minus 6. And for 1, it's just plus minus 1, because there's nothing else but 1. So all the possible rational zeros are going to be written as the quotient of p divided by q. And it's usually best to just start off with just listing all of the factors of p. So plus minus 1, plus minus 2, plus minus 3, plus minus 6. And this is for the reason that q is always going to have a factor of 1. So when you divide all of these by 1, you just get them back. So we know that all the possible zeros here starting off are plus minus 1, 2, 3, and 6. And since q has no other factors other than just 1, because it's just 1, these are all of our possible rational zeros for this polynomial. Next, we have f of x equals 2x cubed plus 11x squared minus 7x minus 6. So again, let's find our p and q. P is going to be 6, and q is going to be 2. So let's state all of the factors of p and q, which is again plus minus 1, plus minus 2, plus minus 3, plus minus 6. So same thing as before. Now for 2, we have a couple more. Again, plus minus 1, but we also have plus minus 2. So let's take our possible zeros for p and q. And we're going to start off by writing all the factors of p. So plus minus 1, plus minus 2, plus minus 3, plus minus 6. And we don't really worry about 1, because dividing by 1 just keeps it. But when we do 2, we're going to get some different ones. So when we divide 2 by 1, we're going to get a half. So plus minus a half. 2 by 2 is just going to give us 1, so we don't have to worry about that. 3 divided by 2 is actually going to give us something new, so plus minus 3 halves. And then 6 and 2 is just going to give us 3 again, so there's no need to state them a second time. So here are all our possible rational zeros for this polynomial. Last, f of x equals 4x to the 5th plus 12x to the 4th minus x minus 3. So we're going to again start off by stating what p and q are. P again is 3, and q is 4. So all the factors of 3, plus minus 1, plus minus 3, and all the factors of q, plus minus 1, plus minus 2, plus minus 4. So all the possible rational zeros are going to be, again, starting off with all the factors of p, so plus minus 1 and plus minus 3. And then we divide everything by 2, and then divide everything by 4. So we're going to get plus minus 1/2, plus minus 3/2, plus minus 1/4, then plus minus 3/4. And here are all the possible rational zeros of this polynomial function.